Hi everyone, my name is Kieran O'Donnell and my talk today is Technology for the Infinite Game. So I'm a technologist, I'm originally from England but now I live in Charlotte, North Carolina, and I work for a company called Avanade. We're a Microsoft focused software consultancy, part of Accenture, and I lead application architecture for North America for Avanade. So a little bit about my background. I've been a software engineer for about 18 years. About 11 years ago, I joined a company called Infusion. I joined them in the UK, and then I moved with them to the United States. And I started off in delivery and architecture, kind of writing code and building systems for investment banks and capital markets. But about 7 years ago, I moved into more of a sales and strategy consulting kind of role. And one of the things that I think was different about Infusion, for a start, they had a whole bunch of really great people. We stayed pretty small and we were pretty selective about who we hired, and we had a really great culture and really great kind of collaborative kind of workplace. But one of the things that I think kind of was the foundation for those is that we had these vision statements on which we would be able to judge all of our kind of business decisions, all of our sales, all of our client interactions. We wanted to do right by our client, empower ourselves, and grow our people. We even structured our annual awards program around those, so you could win awards for doing these things, right? And so that built a kind of different culture. And one of the big things that I learned at Infusion was that we approached business differently to how I think a lot of people do, how maybe the norm is. If we had this method of going to our clients and really thinking about what it is that they needed, that statement to do right by our clients meant we don't always necessarily want to do exactly what they ask for. If we feel like we can give them advice and we can help them to do better, to achieve more with a kind of different kind of project or a different kind of deliverable, then we'd tell them that. And so in the last kind of couple of years, as I've been working at Avanade, who acquired Infusion 3 years ago, I've been trying to kind of talk about this kind of culture and this kind of approach to how we should be consulting with our clients more and kind of training some people and mentoring folks on how to achieve that. And one of the things that I discovered kind of earlier this year or late last year, somebody sent me a video about driving organizational change, driving culture change at a company. And it was by somebody called Simon Sinek. And I'd never heard of this person before, but I really liked the way he spoke about this topic. And so as YouTube does, it kind of recommends me some more of his videos because I watched that one. And as I clicked through them, I got to one talking about the infinite game. And I kind of light went on for me. And I thought, this is a really fantastic, concise way of describing the approach that we've been taking towards business and the way we've been viewing business at Infusion. And so I started to onboard that language, kind of explore deeper, sharing that video as much as I could. And so I really think if we use those kind of ways of thinking, then we might start approaching technology a little bit different. And so I'm going to ask some kind of basic questions to get us started. What if I told you that most people have a flawed understanding about business and the way business works, and they use that flawed understanding to make flawed plans, and those flawed plans probably include poor technology choices, and then those poor technology choices are going to end up limiting everybody's success. And then what if I told you this is all avoidable if we change the way we think about business? And so what we're kind of basing this on is an idea called game theory. So game theory is the study of mathematical models of strategic interaction of rational decision makers. And so strategic interactions means when people are trying to achieve something, right? If there's something you want and you have to interact with other people, that's a strategic interaction among rational decision makers. And so today we use game theory as this umbrella term for like how humans interact all the time. And so broadly speaking, in game theory, there are two types of games. There are finite games and there are infinite games. And so finite games can be defined as having a fixed set of players, a fixed set of rules, and a fixed set of outcomes. So if we think about games like football or chess or international championships for athletics or field or swimming or something like that, there's a fixed set of people competing. Like in football, there are 2 teams, there's a fixed number of players on each team, and there's a fixed set of rules. There's a way to score, there's a timeline. You have to score points in this way, or you have to run faster or swim faster or something like that. You have to, in relay, hand the bat in a particular way. There's a whole fixed set of rules for exactly how it works, how you gain points, and then how you concede them or how you concede fouls or something. And then that all leads us to a fixed set of outcomes. So we typically have a win, lose, or draw situation for games like football or chess or something. We might just have rankings if it's for things like swimming or running or whatever else. But the aim of the game generally is to win. It's to be the best. It's to score more points or concede less fouls or something like that in order that you can be ranked as the best. And so when we think about finite players, we hear them say things like, we want to win, we want to be the best, we need to be number one, have to get the highest score. What is our opponent doing and how do we react to that? Because we have to beat our opponent, right? They're like finite methods of thinking. Infinite games can generally be thought of as the opposite of that. So they don't have a fixed set of players, they don't have a fixed set of rules, and they don't have a fixed set of outcomes. And so, we're saying games, but we're thinking about interactions between humans. And so these are interactions like friendship, or marriage or conversations, things like that, right? So there's no fixed set of players or fixed set of people like involved in friendships. You have lots of different friends. Sometimes you gain new friends, sometimes you lose touch with friends, or you fall out of friendship with people. Marriages can begin and end. Relationships are always at a beginning and ending, right? So there's no fixed set of players and there's no fixed set of rules. There's no do these things and you will be a fantastic friend and this is how you concede points. Different groups of friends, different cultures, different age ranges, different genders may have different kind of standard rules for the way they engage in friendship. And they're all kind of different. And then there's no fixed outcome. There's no end to friendship. There's no like you're friends for 5 years and then you take score and you figure out like which one of you was the better friend and then you're done. You can choose to do another round or you can go get a different friend to go do it with. Right, so the aim of the game for these kind of infinite games is to keep playing. We want to keep our friendships running. We might want to encourage, get more friends and have more friendships running at a time, keep our relationships running, our conversations going. The aim, so there is no kind of win, lose, or draw here. It's just about continuing the game. And so when you talk to infinite players, thinking about infinite games, they're like, how do we make it more sustainable? How can I keep my conversations going or keep my friendships going? How can I help other people be involved? How can I gain more friends? How do I make it more fun to play? Like, what can we do to enjoy this and make it better? How do I grow as players? How do I be a better friend? I just want to do better than I did before, right? These are the kind of mindset when we think about infinite games. And so the question then is, what kind of game is business? Right, so we've got the standard business theory, the shareholder value theory, which I think is one of the dominant theories in kind of economics and in business right now, definitely dominates on Wall Street. Where the primary goal of a company is to increase the wealth of its shareholders by paying dividends or causing the stock price to increase. Right, that's a standard kind of approach to how we do business. We just need to make money, right? So we can make our shareholders more money. And so when we approach business that way, we start to think about we want to be the best, we want to be number one, we need to increase our profits by X amount this year. What are our opposition doing? What are our competitors doing? And how do we react to those things, right? These are all kind of standard business sayings, and they sound very much like the finite players playing their finite games. How do we react to our opposition? How do we win, or how do we be the best? And so what type of game is business, right? If we think about it in terms of finite or infinite games, businesses don't have a fixed set of players, right? There are new companies starting all the time. There are companies going out of business all the time. There are new ideas. There's people that are cross industries. So Costco is a great example of this. It's a big box retailer, but it also is one of the largest seller of cars in North America every year. It also sells kind of insurance products and financial services products, maybe some home improvement products, right? So there's people moving across industries all the time, as well as new companies coming and going. There's also no fixed set of rules of business. There's no guaranteed strategy. This one wins, this one loses. We have laws for the governing of society, but there is no like this strategy, this is what wins. This is the thing that makes you the most money, because there are different people kind of inventing new business strategies. That's what most of the new players are doing, is attempting a different business strategy. And sometimes they win and they maybe take over an industry, and sometimes they don't. And there's no fixed set of outcomes. There is no end to business. There's no date when it's all done, right? We just continue playing the game. We continue in business kind of day after day, needing to do better than we did before. And so if we think of that definition, business is an infinite game, right? And the key part here is that it really doesn't end. There is no done, right? The world moves on every day. There are new competitors joining the game. The rules are fluid. And so like every day, businesses have to move themselves forward to continue playing the game. Otherwise, they'll fall behind and they can end up leaving. They can end up going out of business, right? So this headline on the right is something that will never get printed. Business is over. Let's see who won. There's no International Business Council scoring criteria. We're not going to end up being voted on, how many ping pong or pool tables per office that we had or anything like that. There's no scoring that's going to happen at the end of business. And so if we think about business as an infinite game, what should we be thinking about businesses saying? Like, what should we be hearing them say, all these kind of business leaders? How do we make it more sustainable? How do I improve on what I did before? How do I get a better experience for my employees? How do I get better connected with my customers? How do I make my business more efficient so I can stay in the game longer? But the most important one, I think, is how prepared are we for a big change in the game, right? If there's always new players entering, if the rules are always able to change, and there is no end date, then we have to continue to keep moving, right? We have to continue to keep playing, even if the game changes. And so I think the primary way to do this, and Simon Sinek says this too, is we need to stop competing, right? We need to stop focusing on the competition and win by outstatting your competition. You succeed in the game by improving your value offering and meeting your customers where they want you to meet them, not by continuing to iterate on the same solution just on stats. And so the great example here is the kind of MP3 player, right? So the iPod was not the first MP3 player, and we used to get kind of commercials or adverts for them, like the one on the left here. It's 4 gigabytes, it holds 900 songs, it plays up to 13 hours of music playback, it comes in these colors, right? It's very much about the product itself. Whereas the iPod, wasn't just an MP3 player, it also came with iTunes. But its value offering here is very different. It's 1,000 songs in your pocket. That's exactly how the customer is going to identify it. It's this thing that I can carry with me and I can have 1,000 songs with me. But also because of the fact that it came with iTunes, it actually changed the whole industry about music, right? It changed how you went and bought music. Before this point, there were, primarily people were buying albums instead of singles or individual tracks. So if you wanted a track and it was on an album and you liked it, you'd have to buy the whole album, even if you didn't want all of them. So one of the big kind of hidden things here, the things we forget, is that 1,000 songs in your pocket would also meant you only had to buy 1,000 songs, not 10,000 songs, in order to get the 1,000 that you wanted. So it's a whole change of the industry in favor of the consumer, right? And so they met the consumer where they wanted to be. And so that keeps happening, right? Competition isn't always what you'd expect it to be. If you play to beat your competitors, then you're using this finite mindset. If we're in an infinite game, then new competitors are always entering the market, and you need to think about it as a kind of infinite player. Netflix is a great example. The movie industry did not invent Netflix. They actually resisted it. They originally resisted things like VHS and stuff like that as well, but they definitely resisted Netflix. Blockbuster even had an opportunity to buy Netflix, but they turned it down. One of the reasons being, one of the largest kind of sources of revenue for Blockbuster was late fees. People will borrow a VHS or a DVD and forget to return it the next day, and they would, they'd get charged more and more. And that sounds fantastic for Blockbuster, like it's just so much money coming in from all these late fees. But if you think about it, about where you meet your customers, that is the worst thing for a customer. Like, we hated paying late fees. It's the worst thing about Blockbuster Video was the fact that you paid late fees. And so Netflix's model took that out. People were gonna go to that. Tesla, again, the auto industry didn't invent Tesla. This was an upstart, a brand new company that came in against 100-year-old industries of car manufacturing. And now Tesla's market capitalization is higher than the next 3 car manufacturers combined. Right? They met customers with what they wanted. They wanted a kind of cool electric vehicle that worked. They could really drive somewhere with charging stations and things like that. And so he found a plan to make that work, starting with something expensive like the Roadster that would kind of fund the company to continue to be able to iterate until they get onto the Model 3, which is a much more kind of regular consumer priced car. Airbnb, again, another example. The hotel industry didn't invent Airbnb. They continue to compete based on hotels, on room pricing, on the size of them, or the pool that was added, or something like that. The loyalty programs. But what people really wanted was, when they go visit a city, feel like, what's it like to live there? Find some kind of nice house to stay in for a period of time, and come and go as they please, like they live there for a week or so, right? And that was a whole different experience for the hotel industry, and they didn't really see that coming. They competed based on what their competition was. Marriott competed with Hilton, competed with Quality or whoever. They were just competing on the hotel front. The outlier here is Kodak. Kodak actually did invent the digital camera, but they didn't shift their business model to it. They were a film sales company, and so they made money from selling film, and so they didn't want to switch to digital cameras because it would eat away at their primary business. So they didn't shift to it. So one of the things I want to talk about next is mission and vision, right? So if we're playing the game in this kind of infinite mindset, then we need to have a kind of goal, like what is the thing that guides us, the way that we play the game, the way we meet our customers, what is it that kind of makes sense of it all? And so I think mission and vision statements are a really powerful way to do this. And my primary example here is Microsoft, right? During the Steve Ballmer era, Microsoft were losing market share in a lot of their kind of high revenue products, and they definitely had lost the kind of consumer brand loyalty, right? They were selling Windows and they were selling Office and they were still making money, but they were not a popular company. A lot of people, there's even still a lot of people around now that still kind of dislike the company for that reason. But when Satya Nadella took over, they got a mission and vision statement. Their statement is to empower every person and every organization on the planet to achieve more. And once you get that mission and vision, you aren't focusing on what your current offering is, what your current product is, what the current competition are doing. You get to make decisions on your business based on the kind of company that you want to be, the kind of a goal that you want to achieve, right? So you're able to keep moving forward that way. So they get to decide, hey, we're going to build Azure. Should we allow Linux to run on Azure? Well, typically you'd say no, because you want people to buy Windows licenses. But if you want to focus on empowering every person and every organization to achieve more, then yes, you would take open source on Azure. You would potentially open source .NET and you would make Visual Studio free. And you'd make it run on all the different platforms. Like, these are the kind of decisions you get to make once you have this mission and vision. You get to try and understand what is it that people need to achieve. Like, we all want to achieve more. We want to be productive. So you get to think about what it is that we want to do as consumers of your technology or of your product, and kind of evolve it that way. And so a question I ask is, what would Kodak be, right? So Kodak invented the digital camera, but they didn't shift to it. What if they had a mission and vision statement, right? What if Kodak's mission and vision was to help everyone capture, preserve, and share their experiences and memories with whoever they want, whenever they want? Like, how would you approach digital cameras at that point? Like, they would seem like the obvious evolution towards your mission and vision. You would be thinking, yes, these are perfect. Now we don't need film. We can capture as many experiences as we want. We don't have to develop them to see how they came out. We can keep retaking our photos, right? All the reasons people love digital cameras would have aligned perfectly to your mission and vision. But then being able to share them, like, the reason we take photos is to preserve our memories and share them with our loved ones. Like, we take all our holiday snaps and we come home and we show them to people. So how might Kodak have approached other things at that point, right? These cloud sharing services, like either photo storage or photo sharing, like, Kodak could well have invented these things. These would have been obvious pivots for their business if they thought about business this way. And so I think it kind of shows the power potentially of the mission and vision. So once you think about business as an infinite game and you have mission and vision, then what you'll probably think about next is strategy and tactics. And so Sun Tzu said it very well in The Art of War. Strategy without tactics is the slowest route to victory. Tactics without strategy is the noise before defeat. So strategy are like our long-term goals and how we're planning to achieve them. These are the things that will really give you a path towards achieving your mission. They align well to your mission and vision statements. The tactics are these kind of smaller steps. They're specific plans, specific objectives, specific short time spans. These are the steps that you take to implement your strategy. And so even if you think about the infinite game, you think about this vision that's long-term, like maybe Microsoft did with empowering everyone to achieve more, you still need to decide a series of steps, right? And so if you have a big plan, but you don't plan out your steps, you can still be victorious that way. If you're only thinking steps and you don't have this strategy, which aligns to a kind of real mission and vision, then you're not going to do that well. And so even when we think about infinite games, they still effectively have finite stages. We still need to achieve specific things in order to achieve our goals, right? So that's how I kind of define this kind of infinite game approach to business. So what does that mean for us when we talk about technology? Right. So technology itself, I would argue, is an infinite game. There's no fixed set of players in technology. There's new technologies that get released all the time, it seems, nowadays. There's new things coming up. There's technologies that reach end of life. There's no fixed set of rules. So if you want to succeed in technology, if you want to find the right architecture or the right kind of system implementation to do something, there's probably more than one way to do it. In different situations, there'll be, you'll get varying levels of success. But there isn't one way that says, do this architecture, you will definitely succeed. This different technology, you will definitely fail. Right? So there's no real fixed set of rules to technology. And there isn't a fixed set of outcomes. Technology, the same as business, continues every day. It is in itself a technology business, but even, there's no point when we're going to say, right, that's it. That's operating systems, they're done. We don't need any more. That's web browsers, they're done. That's programming languages, they're done. We're continuing to evolve these things all the time. There is no done, right? And one of the ways that we can see this problem or this situation kind of playing out is with these kind of large technology life cycles that we experience in the technology industry. So these used to be kind of 10 to 15, maybe even 20 years long. So if we think about the gap between mainframes and then PC, like client server applications, that's maybe a 20-year gap between those technology shifts. But then as we get to the web, that might only be kind of 15 years maybe. And then the web to mobile might only be kind of 10 years before those kind of really take off and start changing things. And then we get big data and analytics, we get IoT, we get all these new kind of things in the web. And now we see these shifts are becoming much, much, much faster. So we as technologists who may have used finite mindsets to think about our technology in the past, that kind of worked okay because maybe every kind of 10 to 15 years we'd have to rebuild something and there'd be all the technology shifted, the model shifted, let's rebuild that system. And people were generally okay with that time span. Now, as we see there's only a couple years maybe between these kind of big exponential shifts, we need to be much more ready to kind of change and adapt. And people aren't going to want to, throw everything away and rebuild if it's every 2 years. Right, so we need to start thinking about the kind of infinite rules for the technology game as well. And what we're seeing a lot with this shift as things are really starting to kind of accelerate is the build versus buy balance is kind of changing. So early days in computing, there was no packaged software. So everything that got built specifically for the companies that needed it. But as you get kind of into the 70s through to the 2000s, there's this like explosion in packaged software. We start building kind of general ledgers maybe first as a package, and then we get into things like CRM and ERP and kind of standard business systems, and we get standard business tooling and stuff like that. And that works really well. Like, it's only very unique things that end up with their custom build. But what we're starting to see more recently is while we aren't fully getting rid of packages, there's still plenty of packages that are getting bought. What we're seeing is an explosion of custom software that kind of surrounding them or replacing them, right? And so technology is becoming this big differentiator for business. There's new technologies happening all the time. There isn't necessarily time for all the packages to get built that use all these new things. So if you want to be fast to market with web, with mobile, with voice bots, with chat bots, you need to build some of those kind of custom pieces, even if you're just wrapping them around your packages. And so nowadays we can think of technology as being a big enabler. So when we speak about competitive advantage, what we're really talking about is the sustainable building of customer engagement and loyalty. And so kind of whatever industry you're in, technology is typically the enabler for that now. People walking around with their smartphones, they've got their kind of voice assistants, or they might want kind of chat assistants. Technology enables us to reach our customers in all the places where they may experience that, whether they're kind of searching for products, if they want support, if they want just new experiences or new ways to make their life easier or more productive. Technology is going to be the way that we go meet them do that. And so as we think about technology adoption, adoption of all things kind of follows this kind of standard bell curve. And so right at the front of that, we've got about 2.5% of the market always are these kind of innovators. In technology, this is actually the place where a lot of technology gets invented. These innovative companies kind of trying to scale to new heights or achieve new performance or do new things, kind of inventing technologies, right? They're the real bar setters for what's possible. And then rapidly behind those are these kind of early adopters. About 12.5% of the market will adopt things very rapidly. And so as voice bots became as available, as people were starting to buy these voice assistants for their house, they were the ones filling up the skills market. They were the ones with early websites, early mobile apps, all those kind of things, those straight, like really fast to market kind of people. And then once that kind of part of the industry, once we've reached about 15% of the market have adopted something, what we'll start to see is this explosion as the kind of early majority and the late majority kind of adopt them. And then at the back, there's always this percentage of people we call the laggards, people that will get dragged kicking and screaming because things are being retired or support is ending. And even some of these will even pay other parties to support bits of technology if they don't want to move on. Right, but this is a really standard way that all things get adopted. And so to think about who the innovators are, these are some companies that I've listed. These companies aren't just good with the technology though. They now lead their industries in some way, typically because of the way they use technology. So Uber did not provide a unique physical experience. People have been taking taxis for like 100 years or so, but it's the technology that enabled me to do it on demand and really simple and or on a schedule or pull with other people, like things I couldn't otherwise do. They bought technology to do that, right? It's really become the enabler for them to provide their unique selling point. And then we can think about early adopters. These are brands that succeed with technology, even if it's not their core offering, right? So they pivot with technology, they keep up with the change of the game, and they find success in doing that. Starbucks is like a known kind of leader in mobile order and paid, especially in the food and beverage industry, but in general, like really good mobile app adoption. Chick-fil-A are becoming pretty innovative and early adopters in terms of having kind of small Kubernetes instances or clusters running inside every single one of their restaurants in order to power their IoT and their mobile app experiences and stuff like that. And then, Domino's surprised a lot of people on here. Back in 2002, they started building their own technology platform for a kind of point of sale. Their CEO said that they wanted to make ordering a pizza so easy you could do it at a stoplight, right? He set the company the Stoplight Challenge, I think they call it. And they got that all the way to the point where I could set it up so if I tweeted the pizza emoji, Domino's would deliver me a pizza, the one they knew I wanted, and they charged the card I knew that I wanted them to charge, right? And so these people have driven a lot of success through rapid adoption of technology, through being able to kind of keep up with the change of the game. And so if we think about business and technology being these infinite games, then we really need to accept there's no such thing as done, right? It's always going to keep on moving. We have to continue to improve to meet that, otherwise we're going to fall behind. Industry shifts are going to keep coming, so new competitors, new ways of doing business, new kind of strategies or new ways of meeting the customer. And then the technology that underpins it all is going to continue to change as well. And that's a really key kind of important fact. And so for too long, we've had this kind of mental model about the life of our systems to be like the life of a human, right? And so there's some environment that we're definitely going to operate in. And so we need to build something that's designed exactly and perfectly to fit that environment. But what we often find is that, the world moves on, these systems age, and they eventually lose their fitness and don't survive forever. And so I think the mental shift that we need to start thinking is for long-term success, we think about the fact that our environment is going to continue to change. And so we need to be able to adapt to that all the time. We need to be able to try new things. Some will be successful, some will fail, but we need to be able to continue to adapt to that changing environment. And so it's more about the lifespan of all humans. It's more about this continued evolution in order to continue to be fit for our environment. And so I'd pose this question again. Is evolvability as important as reliability or performance? Right? Should you rank that as high as keeping the website up and running or keeping it moving quickly? I would say yes. This is as important a requirement. And the reason for that is that poor reliability or poor performance, we generally associate pretty well with poor customer satisfaction. So if I come to the website to buy something If I get in your mobile app to see something or to know something or to buy something, if it's unreliable, if the app crashes or if it's slow and doesn't perform well and I got to, maybe keep restarting my task or something like that, I'm going to get poor customer satisfaction. But on a slightly longer scale, if you don't continue to evolve to meet customer expectations, if you can't adopt new technology, if you're a website that couldn't get into mobile, if you couldn't get into voice, or if you couldn't get into the kind of the chatbots that your consumer base needed you to get into, that your competitors were moving to, or the industry was moving to in general, then you're going to fail to keep up with customer expectations. And again, that's going to lead to poor customer satisfaction. There are plenty of industry leaders that weren't able to keep up with the technology changes that we now don't even consider anymore. And so how do we build an evolutionary architecture? So I've got some general ideas that we'll kind of head through. So let's think about evolvability as a requirement. Let's promote that to be one of our kind of first class, I'm going to say non-functional requirements, but even actually a functional requirement is our ability to change. We need to think about likely evolution scenarios. So we've got to find ways to do modeling that enables us to find the ways the system will change. And we can put that to a really kind of basic idea and just say, let's just ask the business team, how do you think the business is going to change? But they're not going to be particularly good at answering that question, right? We need to work together with them to kind of drive those answers out. The next set of advice I say is break the system up along sensible, meaningful boundaries. And so we actually, at Avanade, we use a process called event storming. We use this for both of these things. We want to discover our likely evolution scenarios and break our systems down. So we use event storming to kind of model out the business process, to understand what it is that we're being asked to build. How does the business work? Because we want our software to kind of mirror a kind of structure with that. And so we use event storming and follow that with domain-driven design. But there are other approaches that are very similar, like flow-first decomposition, which Barry O'Reilly talks about when he talks about anti-fragile architectures, or volatility-based decomposition from iDesign. The basic goal of all of these is to model the system and then discover how it's likely to change. So Barry O'Reilly talks about applying stresses to the system. What happens if your competitor drops their price? What happens if the internet goes out? What happens if this or that? We find all these kind of answers to questions, and we do this through our event storming process. What happens if the staff member leaves during this process? What happens if the customer dies during this process? It sounds a little morbid, but one of the worst case scenarios for customer loyalty is when a widow phones up and wants to do something with the account and says, "My husband's just died," and you say, "Well, I don't have a screen for that, so I'm afraid I can't help you." That's a terrible customer experience, but it's very hard to get people to think about all of those edge cases when we're just building, some long Word document as a functional requirements document. And so we want to break down our kind of systems. What we want to do is get things that change together to sit together in the same component, right? So if we start thinking about traditional teams with a UI team and a middle tier team or business team and a data team or something like that, then what we'll find if we have some change in business, if we have some change in strategy for handling an event or a new product that gets launched, we need to get all those teams back together to go build that kind of all the layers, the new UI for it, the new business logic for it, the new database for it. We have to get them all synced up and back together at the same time to go build those things. Whereas if we'd have grouped our system up into these more vertical slices, they'd be much easier to get those. Like we'd have individual teams, and so if we got a whole new product launching, we'd build a whole new team together, and we'll be able to make that work much easier. What we're looking for is for our future evolutions to impact as few number of components as possible. The next thing is testability is a requirement. So we should be making testability kind of like a first-class architectural requirement. We should be, as we design our architectures, as we break down our components, we should be thinking about how will we test this, how we automatedly do it in an automated fashion rather than just manual testing through an army of people driving a UI. Testable architectures are generally better and simpler and less coupled and more evolvable. We start to think about kind of the trade-offs in a different kind of way. We start to think about putting in some dividing lines or some abstractions and things like that in different ways when we think about making our architectures testable. Some tips there, putting business logic in external infrastructure makes things incredibly hard to test, which is one of the reasons behind the microservice principle about smart endpoints and dumb pipes. We want to put all our logic in our endpoints. We make it all testable. If we put in our infrastructure like an ESB, it's going to be very hard for us to test. If we have business aligned components, like if we do our decomposition well, we align our components to match our kind of business teams or our business stakeholders, it's going to be much easier for us to do kind of business aligned acceptance tests. So we're going to have the business being able to, if not write our tests, at least understand our tests, because it's going to be talking about the business concepts that they are kind of intimately familiar with. Having tests at all makes our system easier to evolve, right? If we're able to make changes to our system and then rerun our tests and make sure it still works, that's gonna give everybody more confidence that we're able to actually evolve the system moving on. And so we need these automated build pipelines so we can run our tests. It can be easier to run them and we can run them more immediately. And that's unit tests that we would do kind of during the build process. It might be contract tests. It might be using infrastructure as code, automated deployment, so we can stand up a test instance. We can run smoke tests or integration tests and things like that, right? If we can automate our ability to kind of test a system, and so we define the architecture for it, we've got the automated kind of CI/CD pipelines up and running, and then we've got these automated tests, it's going to be much easier to evolve our system. Last responsible moment decision making is a good principle for evolutionary architecture. This is basically like, don't start a project saying we're going to go 100% .NET Core, we're going to use containers, we'll run it on Kubernetes, we're going to use like the MVC pattern and entity framework as an ORM, we'll do it on Azure, our message broker is Kafka, we do like in-unit tests, all of our requirements are going to be in user stories, right? What do we want to build, right? Like if you commit to all these decisions super early, you don't have enough information to have any confidence that they're right. So the idea of last responsible moment decision making is to delay these decisions as long as possible, but not long enough that it incurs additional risk. So the longer you wait, the more information you'll have. And so you can start to minimize the amount of technical debt that you'll incur because of these decisions. Some of these decisions are going to need to be made earlier rather than later. And so we need to understand what the important drivers are for the system. Like, are we looking for performance? Are we looking for reliability? Are we looking for great customer experiences? Like, then we're going to need to start to think about those things earlier and make some of those decisions. But in all cases, whenever we're making decisions, whether we're doing earlier or later or whatever, we need to start thinking about how easy are they to reverse, right? So if we're picking a message broker, if we start to say, well, we use the standard like AMQP, then it makes it much easier to change our minds about it. If we just say we're just going to use basic PubSub and we can put an abstraction layer around it, that makes it easy to reverse our decision. And same with things like database access or with dividing up pieces of business logic. Wherever we can, think about if we're making this decision, how easy will it be to change it in the future, right? And then another thing I think is really important, which is a concept I like to explain to people at Avanade, is that like a lot of people ask for guiding principles around enterprise architecture, and there aren't that many that are like super easy to explain. But I actually feel like good object-oriented analysis and design principles make good enterprise architecture principles. They're applicable, even if you have to change the way you think about them maybe slightly. But if we think about things like solid, single responsibility, each component doing one thing, like that's a very, that aligns well to our like break down the system to reasonable boundaries and make them business aligned. Let's make our components only do one thing for the business, right? And that's a very microservices style approach. The open-close principle, open for extension, close for modification, aligns well with our like one team per service. We'll put out a standard contract. If you want to, if you want to interface with our thing and extend it, you can do that through our contracts, but only that one team is going to be able to actually modify our service. The discourse substitution principle, that's basically polymorphism in OOAD. But for in a microservices world or in a distributed systems world, it means we should be able to evolve the implementation of single components without breaking the rest of the system. They can do the same general idea for the business, but they can do it in a totally different way with a new implementation, and that shouldn't affect the system at large. Interface segregation principle. This is about doing decoupled integration, about having more specific contracts. The same way you do that for objects, you could do that for services too. And then the dependency inversion principle is another good one. In OOAD, it's dependent upon abstractions and not concretions. But I think when we're thinking about enterprise architecture and distributed systems, it's loose coupling. It might be things like brokered communication. It'll be contract first development, like all those kind of principles. So we're able to think about the way we would will interact with general ideas about services rather than specific services at specific IP address, port number. This is exactly the thing I have to send. We can maybe think about things like our message contracts as being our interface, our abstraction, and then I can publish on the bus, and there's a general idea about what will happen with that message when it goes out there. And then graph. This is another set of principles like solid, but a lot of these things still apply the same way. Indirection using facades and adapters is kind of a bit like the dependency inversion. Information experts about encapsulation and information hiding, which is a bit like the substitution principle. We should be able to evolve our pieces, have like independently, and we should have kind of limited kind of API services for how we'll interact with them. Low coupling and high cohesion and polymorphism, like very similar ideas. They work very well for object-oriented design, and they'll work very well for when we apply them to enterprise design as well. And then one of the other things I always kind of tell architects and people who are thinking about how do we keep our systems evergreen. Architects are for life, not just for Christmas, right? So we have to continue to adapt to change. There's no point saying, we've bought into the infinite game. Our software is going to need to be evolvable. So evolution is going to be one of our core non-functional requirements or even functional requirements. And we're done, start building, and the architect can leave. Like, we need to continue adapting to that change. Our architects need to own the system long term. We need to keep working to model the stresses of the system, the changes that might happen, the likely evolution patterns that we're going to see, and then keep adapting the design as needed, right? And then when we start with these principles, like solid or grasp or whatever else, we need to make some quality metrics so we can measure our ease of change, our complexity, our understandability of our system, and we can continue to monitor those. If we go down that testing path with automated testing, we should be able to write tests for these things. We should be able to do analysis on the code to make sure that our code aren't breaking any rules. And then we should be able to set up things like fitness functions for our architecture concerns. If I always want to be able to take orders, even when my logistics service is down, or if I want to be able to send like different types of emails or things like that, we should be able to set up tests where we can automatically deploy to an environment, turn off the logistics service, and make sure we can still send orders. Or whatever our architecture concerns, whatever our points are, we need to be able to kind of keep testing those things as we move forward. Keep owning the architecture, keep evolving it, keep assessing it. And so to sum up, business is an infinite game, right? Change is constant. There aren't a fixed set of players, there aren't a fixed set of rules, and there is no fixed set of outcomes. So evolutionary architectures are ones that are designed to enable change. Not just capable of it, but it's really one of their first class requirements. And so to achieve this, we'll do iterative and agile architecture design. We're going to come up with our principles first, and we're going to delay our specific decisions as long as we can. We're going to orient them around kind of components with standardized and testable contracts. We're going to use simple, appropriate communication mechanisms. We want to keep our coupling low. We want to kind of make our general communication mechanisms our method of abstraction and our APIs. I generally think a really good kind of first point for that is brokered communication and event-driven architectures, and they enable that really easily. And so we want the appropriate level of coupling between our components, as I said, contracts first. And then we need to continually test and monitor and adapt at all levels with automation. So unit testing all the way down to kind of smoke test and integration tests. And we should be doing that as frequently as we can. And so I'm just to show some further reading and references. The first talk here is Simon Sinek's full Infinite Game talk. The one I watched to the Nordic Business Forum in Sweden. We've got a video on volatility-based decomposition, anti-fragile architectures, and then there's a book from three folks at ThoughtWorks about building evolutionary architectures as well. So these are some of the sources and places where I get my information knowledge, some of the influences on me for the contents of the talk. So thank you. Any questions now?